Hello, this is a video just to review how to write equations of parallel lines, and let's get started. The first thing I want to just review is that parallel lines always have the same slope. I'll give you a couple quick examples. So one with some positive lines. So let's say I have line A with a slope of 1. We'll call it slope m equals 1. And I can have another line parallel to it, but if they're going to be exactly parallel, this little symbol designate parallel, and I call this one line B. Well, line B also has to have the exact same slope, 1. If they're not exactly the same, then they are not parallel. And they're going to have different y-intercepts, but the slope will be identical. So this is an example of positive slopes. I'll do some with some negative slopes. Maybe this is negative 2/3, and this one also would be negative 2/3. Okay? So with that fact, let's try it out. The problem is to write an equation of a line parallel to this equation here, y equals 2/3 x minus 7, that goes through 1 comma negative 5. All right, so really all we need from this first equation is this part, the y equals 2/3 x. In fact, what we really need is the 2/3. We don't need the y-intercept. It's completely irrelevant. I can just cross it out. So what I know now is that I'm going to write an equation of a line that's got a slope of 2/3. And it goes through this point here. So the first example I'm going to give you is in in point slope form. All right, that's y minus y1 equals m times x minus x1. And I'm assuming that you've done this before. All we're really going to be doing is plugging in our slope 2/3 right here. Okay, and then of course the y and the x are just kind of always there. The values for y1 is going to come from this point here. So since I would be subtracting a negative 5, it's going to turn into y plus 5. And then after the x, we're going to have minus x1. Well, the x1, or the value for the x in this particular point, is 1. So it's going to be x minus 1. And that's all there really is to it. That's probably the easiest way to do it. Next, I'm going to show you how to do it in slope-intercept form. This is the exact same problem. I'm wanting the equation of a line that's parallel, this means parallel, to this equation through this point. Well, again, all I really need is the slope from this equation. All right? I know that my new equation is going to be y equals 2/3 x plus or minus some number here. And we don't know what that number is. I'm just going to call it b. But I do know that since it goes through this point, 1 comma negative 5, those values for my x and y have to work in my new equation. So let me go ahead and plug them in right now, and I'm going to figure out what b has to be for this to work. So I'm going to plug in negative 5 for my y, and 2/3 x is going to turn into 2/3 of 1 plus b. We're going to solve for b. So negative 5 equals, well, 2/3 times 1 is just 2/3 plus b. Right, I want to isolate b, so I'm going to go ahead and subtract 2/3 from both sides. And I've got 5 and 2/3 is equal to b. Well, I'm going to rewrite negative 5 and 2/3 to, let's see, well, 5. I'm going to convert 5 times 3/3 is 15/3. So if it's negative 15/3 plus negative 2/3, that's negative 17/3. I like to write my y-intercept in a fraction. So my new equation is going to be y equals 2/3 x minus 17/3. That's really all there is to it. Might have time for one more example. Sometimes you get questions where you're asked to decide if two lines are parallel.